Arduino Uno equivalent board, breadboard, stepper motor driver board. Red LED will be on when motor is running. Green LED will indicate direction. When it's off, counterclockwise. LED is on, clockwise. Start-stop button. Second one is the direction button. Let's go ahead and start the motor. Watch the motor. Red LED is lit. Stepper motor is running counterclockwise. Why counterclockwise? That's the default. And the LED is off. Green LED is off, indicating counterclockwise motion. Let's change the direction. Watch the motor. Pressing the second push button. Motor has changed direction, now going clockwise. Green LED is lit, indicating clockwise. Start again. Start. Stop. Start. Stop. Start. Change direction. Counterclockwise. Clockwise. Counterclockwise. Clockwise. And there we have it. Here's an example schematic. Some of these we've seen before. Incidentally, this diagram, the previous schematic, was intended to work with Sketch Lecture 5 Demo 4, the one that we previously discussed and the one that the video was about. Again, how does it work? Start-stop switch S1 turns the stepper motor on and off, and also LED 1. We say there are green and red LEDs. You may choose to use some different colored LEDs for LED 1 and 2. That is totally your choice. Direction switch, that's push button S2, controls the direction, clockwise, counterclockwise. Also controls LED 2 on-off state. Resistors are there to provide limiting, current limiting, and also, as stated previously, Arduino pins 8 through 11 control the stepper motor driver, which in turn controls the stepper motor. Stepper motor driver uses the chip that we mentioned earlier, which has basically 7 transistor switches on it. Contains multiple transistors, but 7 different driver switches, if you will. Here are some pictures of the hookup. Here we see the Robo Red in the upper left. Lower right we see the stepper motor driver board. Here, see these LEDs labeled A, B, C, and D. Notice when the stepper motor is running that these will be flickering because these are turning on and off very quickly, providing the drive pulses to the stepper motor so that it sequences as it rotates in one direction or the other. Coils are sequenced and the stepper motor goes tick, 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 tick and steps very quickly. Here we see the push buttons and resistors, dropping resistors, and the LEDs. So this is basically the operator control panel for the stepper motor. Motor control flowchart should look very familiar. This is what we saw earlier. We used this for a demo of the interrupts. This example matches the demo program, Lecture 5 Demo 4, mentioned previously, Lecture 5 Demo 4. This flowchart matches that program, however, it does not match the upcoming homework assignment. MCU Homework 2 is based on this, but you must do a slight modification and the flowchart will change. Next, let's take a look at the microcontroller assignment MCU Homework 2. This needs to be done by each and every student. You must use your breadboard, connect the components as shown previously in the photos and the videos, program the Arduino to do everything that Lecture 5 Demo 4 does, which was the previous example, and again that was in the video. It's going to do everything that does and more. Noting the red highlighting here. LED 2, the second one, whether it's green or red or whatever color it is, that LED needs to blink when the motor's going in the counterclockwise direction. It needs to be on steady when the motor's going in the forward direction. So, going to need to change the programming logic just a little bit. Makes a whole lot of sense to use Lecture 5 Demo 4 as a starting point and just modify that to add this new functionality. You must create and print new flowchart. One of these links here would be an easy place to start. I might suggest the second one since it basically contains the flowchart from the previous page. You can just edit that. You need to add the functionality for that blinking LED. Then going from the flowchart to modifying the program, you need to make that happen and then bring it to class to demo and turn in printout of the flowchart. Again, each individual student must do this.